Now we will see another new chapter, that is scales. The scales is a small chapter, but it is having a major importance in the drawing, right? The first one, why the scales are required? What is scale? Scales are very important, particularly when we represent very small objects on the drawing sheet and very large objects on the drawing sheet. Okay, suppose if we draw a pencil having around 15 centimeters length. Okay, we can draw the pencil with the true dimension. Okay, that means whatever be the real length, whatever be the original length, okay, that length we can consider, we can draw. Or if you consider a small box of 10 centimeters into 5 centimeters into 5 centimeters, okay, that box we can draw with the exact dimensions. But if you go for representation of large areas, suppose acres of areas, if we going to construct some factory or housings, okay, houses like that, then to represent acres of land on a drawing sheet, original dimensions we cannot maintain, but we need to reduce the scale. Okay, we need to reduce the original dimension of that land with some scale factor, and with the reduction scale we need to represent that on the drawing sheet. Then we can accommodate that drawing on the drawing sheet. Suppose a component is very small, okay, just like a resistor or garb screw, okay, or rivets. Okay, very small details if it is present on a sheet or on a machine component. Okay, suppose if you want to show those minute particles very clearly, then we need to go for enlarged scale. Okay, even though if it is 1 mm, we may require to show with 10 mm. Okay, that means its size is enlarged. Therefore, the scale what we use, that is enlarged scale. Okay, that means scales are very important for the drawing sheet, to draw those objects on the drawing sheet. When the object is very large, we need to use reduced scale and we need to draw the respective drawing. If the size of the object is very small, we need to enlarge the dimensions. Therefore, we need to use enlarged scale. And the object dimension is convenient to represent on the drawing sheet, we can go for exact scale. Okay. Now, I introduced 3 terms. These 3 terms once I list out here. One is exact scale. The second one is reduced scale. The third one is enlarged scale. Enlarged scale. Okay, now exact scale no need to explain more because whatever be the original dimensions of the object, if we consider those dimensions, if we draw the respective drawing, the drawing is drawn at exact scale. Okay. Now we go for the reduced scale. Suppose the original drawing object length 100 meters. Okay, original object length or original length, if it is 100 meters, on the drawing sheet, drawing length if we represent with 10 mm or 100 mm, okay, Here 100 meters is represented with 100 mm. That means the scale is downed or it is reduced. It is a reduction scale. Okay, reduced scale or reduction scale. Okay, how much it is reduced? How much it is reduced? That we need to find. Here 100 mm. Okay, divided by 100 meters. Okay, while dividing, both should be in the same unit. Okay, either numerator unit or denominator unit. Okay, 100 mm and 100 meters. 100 meters means meter having 1000 mm. Okay, now see. Then 1:1000. Okay, 1:1000. We used this is the scale factor. Okay, this is the scale factor. 1:1000 is the scale factor. That means, suppose if you consider 100 into 1/1000. Okay, this will gives us. Okay, and here 1 meter equal to 1000 mm. Therefore, if you put point, this is cancelled 100 mm. Right, here see, we got the scale factor. Once we calculate the scale factor, if we multiply the scale factor into the given dimension, that will give us the dimension which we should consider on the drawing sheet. Okay, on the drawing sheet, what is the length we need to consider? That length will obtain by considering original length into scale factor. Okay, that scale factor also called as representative factor or RF, object scale. See, original length of object, let it be 10 mm, and we represented that with 100 mm. Okay, 10 mm object is represented as 100 mm on drawing sheet. How much it is enlarged? Okay, it is 100 mm divided by 10 mm. This is 10. That means it is 10 times enlarged. Right? Right. Then the scale factor is 10:1. Okay, representative factor is 10:1. Right. Now here I want to give a formula for representative factor. Now representative factor or scale factor. Representative factor or scale factor. Scale factor or representative factor, that is equal to drawing length or the length of the object on the drawing sheet divided by original length of the object. Okay, that will give representative factor. If it is 1/1000, 1/100, 1/2, 1/5, if it is like that, okay, then it is a reduced scale. Right? Suppose if it is 10:1, 100:1, okay, 5:1, if it is like that, then it will be enlarged scale. Okay? Then here the drawing length is equal to representative factor or scale factor multiplied with original length. Okay? These things the students should remember regarding the scales basic. Now, what are the different scales generally used in the engineering drawing? Here 5 types of scales used. One is the plane scale. The second one is the diagonal scale. The third one is the comparative scale. Fourth one is the vernier scale. Fifth one is scale of cards. Okay, these are the 5 types of scales used in the engineering drawing. First, I will explain what is a plane scale. I will take one problem. After that, I will tell the explanation about plane scale. Note down. A scale, construct a scale of 1:4. 1:4, that means RF, representative factor, equal to 1:4. To show centimeters and long enough to measure 6 decimeters. To show centimeters and long enough to measure 5 decimeters. 3.8 decimeters on the scale. Okay, note 3.8 decimeters on the scale. Right. Now this is the problem given. Here see, the scale need to show centimeters and decimeters. Centimeters and decimeters. And what is the maximum length? That is 5 decimeters. That means in that drawing, the maximum existed length of the object is 5 decimeters. That means if you construct 5 decimeters scale nearby the drawing sheet, okay, or on the side of the drawing sheet, then whatever be the dimensions below that, directly we can measure from the scale and we can put the same dimension in the drawing very easily. Okay, it is a graphical method. Okay, whatever be the scale we required, already it is constructed there by considering maximum length in the drawing. Okay, after that respective scale is directly used in the drawing. Here see, RF is given and maximum length is given. First, what is the length of the scale we required to draw on the drawing sheet? That we need to calculate. First, length of the scale. Length of the scale we need to calculate. Length of the scale is equal to maximum length of the object into RF, representative factor. Okay, now maximum length is 5 decimeters, right, into RF equal to 1:4. Therefore 1.25 decimeters. Okay, 1.25 decimeters. Okay, but we need to draw that in centimeters. Okay, 10 centimeters is 1 decimeter. Okay, therefore if you convert this into centimeters, therefore 12.5 centimeters. Right. Now the maximum length of the scale equal to 12.5. Now draw a line and to represent the scale around 10 mm you can consider. Okay, the total length, this is 12.5 centimeters. Okay, this length is equal to 12.5, okay, centimeters. Right. Next one. In this scale, for the sake of our easiness, okay, for our purpose, you can draw. Here you can consider 3 mm, here 3 mm, middle 4 mm it will be, okay. You can draw a line like this. This is construction for the purpose of increasing the visibility only. Right? Now divide this whole length into 5 equal divisions. Okay? See, 12.5 centimeters equal to 5 decimeters. If you consider 5 equal divisions over this, obviously each division is 1 decimeter. Right? Now, construction. You know how to divide a given line into number of equal divisions. Okay, by considering that method, this is an inclined line, and consider 5 equal divisions on this. This is 1 dash, this is 2 dash. These divisions must be equal, any length, but it should be equal. 3 dash, 4 dash, and 5 dash. Right. Next, we need to join the end point and last division. Right. Now parallel line to this. Right. Okay. Now this is one division. This is other division. This is one division. And this is one division. If you consider exact scale, you got right equal divisions. Okay, this division seems to be lengthy, but if you take exact scale and exact parallel lines and everything, all will equal, right? Each diameter. Okay. Therefore, here put 0. Okay, and the right side portion we want to show decimeters. Therefore, this is the first division, 1 decimeter, up to this 2 decimeters, up to this 3 decimeters, up to this 4 decimeters, and this division, 5th one, right? This one is decimeter, therefore you need to write decimeter. Decimeter. Now, 1 decimeter is equal to 10 centimeters. 1 decimeter is 10 centimeters. Then divide this into 10 equal parts. For that also, you need to consider an inclined line here and consider 10 equal divisions. Okay. 1. Now you need to draw a line in between the end point and the last division, 10th division. Right. Now you need to draw the parallel line to this line. Right. This I can note here. Get here. 1, 2, 3, 4, 5. These are centimeters. Therefore, here you need to write this is centimeter. Okay, that means centimeter again. Okay, here to distinguish these two, okay, we can give darkness or hatching at this portion. Okay, if we put this, obviously or in the drawing sheet you can give hatching also. No need to darken. It will take time. At the same time, perfect darkening also it is somewhat difficult. You can give hatching also. Anything is preferable. Right. This is the plane scale. Okay. In the plane scale, what we observed? Okay. In the plane scale, we consider the maximum length. Considering maximum length, multiplying with the RF, what is the length of scale? We calculated. After that, divide the scale according to the number of divisions required for the maximum length. Okay, and we put 0 at the first division. Okay, this is after completion of first division. Here 0, and here the decimeter in the scale it is given, and here centimeters. Okay, likewise we need to mark, and respect to decimeter and centimeter we need to locate at the respect to left side and right side. Right. Okay. Now asked to locate 3.8 decimeters on the scale. 3.8. Here to here 3. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8. Up to this, if we consider, this is 3.8 decimeters length. Is it not? This is 3.8 length. Okay. This 3.8, if we require, we can. Or if you want to look at 2.6, this is 1, this is 2. After that 1, 2, 3, 4, 5, 6. Okay, here. This is 2.6. Likewise, any length we can measure from this scale.